The recording is taking time somehow, I don't know. So, good morning, everyone. We have finished the course, okay? But this is just a beginning for you guys. As I said, there may be like a lot of advanced courses that if you're interested, you can do later. Yeah, during your graduate studies and all. Yeah. Anyway, so chapter 10 only the tutorial is remaining, so we will do it today. And we will see. Okay. Main thing is understanding. All the details can be coded. What you have to know is understand and accordingly how to solve it. You know the process. Process is not like the general process. Process is exactly you know what to do. Let's solve the 10.1 and as per which, so problem goes something like this. Yeah, and you have so this is the fixed at left end, the other end is pin joint, and then px which is loaded like this. Okay? Word, so px which is a distributed load, constant load. So it says consider a beam AB subjected to uniform transverse loading as shown in the figure. Using a single finite element, calculate the maximum deflection and compare the solution of the elementary beam theory. Yeah, so it says first you say the solution from elementary beam theory. First thing will be this is the beam. Yeah. So first you can solve as what? Remember, for uy over dx for pi is equal to dx. So first thing you solve it as an analytical problem and you find out what the solution for this is. Yeah, so this is universal in all beam cases. This is how the solution is. In fact, I can change. So in fact, the correct is like this. If E is a function of x, if I is a function of x, then it should be like this. If I as constant, then only it will go up. Remember that, okay? So this we have seen earlier also. So if I is changing, the area of cross section is changing, hence the I will also change, and accordingly you have to put this inside it. Similarly, if E is changing, material itself may be graded, meaning that gradually it will the Young's modulus may change. In that case, you have to keep it within the bracket. Yeah. So for here, EI is a constant. Okay, so this becomes this. Yeah. And apart from the equation, you also have to know the boundary conditions. So what is the boundary conditions? So this you have to, problem is given, you have to find out the boundary condition. So you tell me, what is the boundary condition number 1? So is x equal to 0, say x equal to L. So first will be displacement, so uy at 0 is equal to 0. Number 2 is so duy dx at x equal to 0 is also 0. Number 3. Uy at L is equal to is maximum. It is fixed. It cannot go up and down. So it will be 0. Okay, and now 4. Slope is here 0. Pinch joint, no, there is a difference between this and here. This is the slope is also restricted, right? It cannot rotate. It is like fixed joint, right? You are fixing it. Here there is a pin joint. If you have a pin here, you can always go up and down. So rotation degree of freedom is not restricted here. So what is the boundary condition? Moment is 0. That's the correct answer. So moment is 0 means I square uy over dx square, or simply the double derivative of uy is equal to 0. So these are the 4 boundary conditions. Based on that, you have to solve. So first part is solving analytically, and that you can do it. And what you have to do is keep on integrating, and finally you put all those values. You can do it. That is the solid mechanics. Yeah. So that is we will. I hope you will be able to do it, right? This is a differential equation. You have to solve it where px equal to p naught, right? So you have to solve this one. Finally, will be what? So ei d cube uy over dx cube will be equal to p naught x plus c1 and so on, right? You have to keep on working, and you can square uy over dx square is equal to p naught x square over 2 plus c1x plus 2. Similarly, I duy over dx is equal to p naught x cube over 6 plus c1x square over 2 plus c2x plus c3. Then ei duy over uy is equal to p naught x4 over 24 plus c1 x cube over 6 plus c2 x square over 2 plus c3 x plus c4, right? And then you will put these conditions uy equal to 0. So automatically from here, what do you get? C4 is equal to 0. From here, right? From here, what do you get? So you see here, right? This whole thing equal to 0. So C3 is equal to, right? Now you have these two equations. So even this at x equal to L. Remember, this is at x equal to. Rest is UL equal to 0. So finally, ei uy x is equal to of this form, right? So you have C4 and C3 equal to 0. So you just have this thing, yeah. And then you have two constants that you apply, 3 and 4, right? And then you can find the solution, right? Yeah. Anyway, this we don't want to spend much time on this one. You have to find out these two. C1, C2 from this will give you gives C1 and C1. So you do it. Now second part, it is telling that you take two noded elements and you solve and you find out what the value is. Right? So you have this uy1, theta 1, uy2, theta 2, right? So only thing remaining here is what? Okay, now maximum you have to find out. So how will you find out maximum? For maximum, you will have this equal to 0, right? And if that is 0, then you can also solve it. You can find it. Yeah. So see here, maximum will be. Let me do this later. So for maximum, duy over dx is equal to 0. That means p naught x3 over 6 plus c1 x square over 2, right, is equal to 0, right? So solution gives you x square p naught over 6 x plus c1 over 2 is equal to 0, right? So x equal to 0, that it gives you the, here the slope is 0, right? So hence x giving you, but it is not the maximum deflection. Maximum deflection is somewhere else. So x not equal to 0, so you get x equal to minus c1 over 2 multiplied by 6 over p naught. So it will be minus whatever the c1 is, you have to find out. So 3. So this will be the answer. X equal to minus. Oh, c will be minus. It will be minus. Hence, we will get positive. Yeah. So anyway, this is. You are understanding the solution? Any problem? So this is how you found out, right? So this is continued from here. Now coming back to this one, we have to quickly solve it. And what we see is there are 3 things. You will have k, u equal to f, and k is 4 by 4. And we find out what that is. And u is equal to what? If you see in this case, what happens? First entry will be? First entry? 0. First entry is this one. So this equal to 0. This is equal to 0.
Just a second. Where is it? C2 1.
C2 will be there in Y2, na? So
Yes, it's a maximum.
yeah, we made a mistake. We have to also write. No, C2 equal to 0.
No,
this is not equal to 0.
right.
Yeah. Yeah, so you have to solve according to this. I think this will be C2x. Yeah, so accordingly, we have x square x plus C2 is equal to 0. And then you have to find out, right? So we find x equal to quadratic equation, you have to solve. So x equal to. So the one which is positive, you have to take, right? Yeah, so you find out. Now uy1 equal to 0, theta 1 equal to 0, uy2 is equal to, and theta 2, do you know?
No.
Yeah. Now force F is equal to, what do you have? What is the force? There will be 2 types. One coming from the end moments, right? So end moments are, we can write F because of the boundary, right? So, or these are end moments, so you can write, let's say, call it boundary, gamma, and the other is because of the body force. Okay, where if gamma is equal to what? From the boundary as far as concerned, we will have the, it's not zero, man. That's a reaction coming there. So we'll have R1, this is R2, right? And then here also there will be R3, and then here M2, or we call it M2 is equal to 0, right? Fine. Or you can also write is equal to, reaction is fine, R2. R2 is actually moment is there. It's fine. Okay. So there is no moment. So that's why you are writing here. So this will be equal to R1, will be R2, then you have R3, then equal to, then C transpose of that. So these are coming because of the boundaries. Right? Now because of the body X, that another thing we have to find out, and that how we need to. So let us say P given by, let us say 1, F2, or you can say force V1, moment V1, force V2, moment V2. Transpose of here, if V1 is equal to, you can just do half. Half forces will be half, but you don't know how. That's the thing. How much have you calculate? Yeah, but the forces will be half, but you can see how do you do it. See, so it will be not N1 over L square or Q? Q X minus L square of it, then 2x plus L. Yeah, we get 0 to L. Yeah, will be equal to what? You have to expand it. It will be easier. 0 to L over L cube and x square minus 2xl plus L square 2x plus L. Right? Fine. I think there is a. Okay. Now what? Yes. I think there is a faster way of doing it. Equal to Q naught over L cube 0 to L, and what we will write is 2. Here we will this will be 2x plus L equal to 2x minus 2L plus 3L. Okay, so we write like this one, so that we have x minus L cube of it multiplied by 2, right, plus 3L x minus L right? Yeah, and this is equal to P naught over L cube, and then here we go 2x minus L Q 4 over 4 plus 3L x minus L cube over 3 0 to L. So L 0, both of them, and P naught over L cube multiplied by L here 0, both 0, 0 here, so becomes minus half L4, right? And this will be plus, right? Plus the 3 cancels out here. So L4 divided by just L4, right? L4. Should be L4 only, otherwise we want half, right? So what you get? P naught L over 2. That's what we wanted, right? So this is nothing but we get this guy. So basically we are getting this equal to P naught times L over 2, and that we are getting from here. So I was saying that what is that? Total force, half of it goes there. Simple as that. If half goes here, the other one also goes half. So you know that this guy is P naught L over 2, and this will be also P naught L over 2. Both of them you will get the same. Yeah. Now these two guys, this one and this one. Yeah. So what will be the value of this? So this, in fact, we did not need to, in order to solve all those things, we did not need to actually find out this one. Why? Because if you see here, this is just the one example I showed. Yeah. But in this case, what you see is only θ2 you have to find out. And k you multiply by this one. Only thing remains is the k44. What is the equation remaining? The equation remaining is k44 multiplied by θ2 is equal to so k44 divided by multiplied by θ2 is equal to whatever the values are here. So we get 0 plus MB2. Right? So 0 plus MB2. So you no need to waste time in finding out all this. And you can get immediately. Just what you have to do, what is K44 and MB2. We wasted time here. No need. Yeah, unless you have to find out the reaction forces and all, then you have to find out. Otherwise, no. Okay, so what is MB2? What is MB2? K44, you tell me what that will be. K44 you know, right? Will be 4EI over L. AB MB2 is equal to N4X P naught dx 0 to L is equal to 0 to L. Tell me what is value of N4? What is N4?
X
X square.
X minus L over L.
That's it. Okay, this is will be easier. P naught L. Okay, x cube over n square. X cube minus L x square dx is equal to P naught L square, and then you have x 4 over 4 minus L x cube over 3 L over 0 is equal to P naught over L square, and then you have L4 over 4 minus L4 over 3 is equal to, then what do you get? So 3 is minus P naught L square divided by is that correct? Yeah. So you put that values here. F44 is 4EI over L. Yeah. You can see here this multiply by radian is equal to moment. So this should have a unit of a moment, right? And this one is what? E multiplied by I. Newton meter square divided by meters and Newton meter. This is equivalent to unit of a moment. So it's correct. Okay, now so this we got here. Then theta 2 is equal to MB2, which is minus P naught L square over 12, and we get theta 2 is equal to minus P naught L square over 12 multiplied by L over 4EI. Yeah. So what do we get? Minus P naught L cube over 48. Yeah. So this is theta 2. So what it tells you that the minus because this guy. So since this is like this and it is upward, yeah, so this will go like this. So this is going clockwise rotation, and hence you have minus. So that is correct. Yeah. So once you have that, then what? How do you find out the maximum? So according to this finite element analysis, you will have N1 Uy1 plus N2 theta 2 plus N3 N3 Uy2 plus N4 theta. Now this is 0, this is 0, and what? This is 0. What you have to this one? So U this is equal to N4x multiplied by theta 2, and theta 2 is this. So it's equal to, what is N4? N4 we already have this, so x square x minus L over L square multiplied by theta 2, which is equal to minus P naught L cube over 48 pi. Right? So you have this minus P naught L, right, divided by 48 pi, right? Then you have x square, x minus 12. This is what you y x is. Yeah. And you have to find out the maximum. Now you can find out the maximum of it. Right? So for maximum deflection, dy over dx is equal to 0, and from there you can see, right? So that tells you minus P naught L 38 pi, and then you have 2x minus L plus x square. Yeah, that is equal to 0. So either x equal to 0, which is not correct, right? Or you have, so okay, so we get 2x minus L plus x is equal to 0, right? So 3x equal to 2L, x equal to 2L over 3. Which may be different from the identical solution. Yeah, most likely. If you see, like we had a quadratic equation that we solve, but in this case also it is quadratic equation. It may be the same one, or the exact solution. What is the nature of the exact solution? In the exact solution, did we have x to the power 4 or 3? We had C4, right? P over. Did we have like this? Yeah. Then exact solution may not be same as this one, because exact solution is x to the power 4. Approximate solution is x to the power 3. So solution may not be, are different basically, and hence exact location, it will give you different location. But still it will be somewhere there. Yeah. But this is the idea. This is how we will solve. So always see the problem, see which all things you have to find out. Right? Not necessarily you have to find out. Like typically I get this kind of answer. I did not have much time to solve it because finding out the stiffness matrix took a long time. But in this case, what? You have to find out just one. So think that which all things you have to find out. Got it? Yeah. So you have to also apply your mind, no? Of course, like if you start finding out each element of that, each entry of the stiffness matrix, this will take a long time. But if you apply your mind, to find out which exactly you have to find out, it's very fast. Any question now? This side, or maybe I start a new problem, so I will start from here only. Okay, now you can also combine two types of things. Yeah, and what I mean to say is the second problem is like that one. Yeah. But by the way, if you have a problem in which you have a, I'm just telling you from, like you have a bending problem, at the same time you also have a axial force. Axial force is applied. right? So you may have this force applied, there will be this force also, there will be this also. Similarly, you have this force and moment as well. You see, how many degree of freedom here? 3 degree of freedom. Here 3 degree of freedom. This is called frame movement. It is like a, if you build it both the sides, it's like not only building, but it is the one which can take axial load, right? So it is the area is also good. Yeah. So in that case, what happens? What you will do is you will find out, you will write the degree of freedom. So 1, 2, 3, 4, 5, 6. Right? Now for beam K, there will be some value right here, 4 by 4. So you will have K11, K12, K13, K14. But here, this for beam, but here the degree of freedom corresponds to is 2 and 3. And then here, sorry, this becomes okay. 3, 4, 5, 6. So you have 2 and 3, and then you have 5 and 6. So these will correspond to 2, 3, 5, 6 in global. We are combining two kinds of element together. One is the beam element, the other is the axial bar element, 1D elasticity, remember? For beam K is like this, and 1D bar element, where K was, if you remember, we call it EA over L, 1 minus 1 minus 1, 1, right? Remember? That will correspond to 1 and 4. 1, 4, 1, 4. Right? So this will be the beam, this will be bar, you assemble them together. Global will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This will be 6 by 6. Right? You can combine them together. Now, this can take also the load, axial load now. You have combined two kinds of elements into only one. Right? So, beam element and 1D bar element combined together becomes a frame element. And this is what the frame. Yeah? You have this kind of problems here. Okay? So, not only this, anywhere you can also, now you can also have, let us say, torsion element combined. Right? You can also have a torsion here. Means one more moment you can also introduce there, right? In that case, you will have one more degree of freedom, which will be a moment about this. So you will have global matrix 8 by 8, and so on. So that's why I said this is the beginning. So you add based on it, automatically you will add more things and you will solve. Now is little bit different, but actually this is also inspired from there only. Yes, there is no, but what it says that whatever we solve it, it is the same one. But we have like this. Upward forces. Okay. And then you have L, And then you have this bar as the truss element. Right? So this is truss element. Bar we call it, or truss element. This is beam. Now, how to solve this? It is said that this is L over 2 from here to the L. You have to solve this. How to solve it? Difficult? Easy? Okay. You will do for beam first. Find out what the K is. K is the usual, whatever you remember. The same thing, 12 pi over LQ, is it? And so on, right? So whatever you have will be here and here and here. So you have that 4 by 4. You will first put the degree of freedom. You have to assemble in the global matrix, right? So degree of freedom. So what are the degree of freedom? Here you have 1, 2, 3, then 4. Right? Now this is hinged here, and this one is a bar. This is a truss element that you cannot take bending. You will just take the axial loading only. Yeah. So this one is going. This is going to be a hinge basically. It is like earlier only. Yeah. This is going to be a hinge. And then you have here. So what is degree of freedom here? Just this direction. That's it. Yeah. It cannot take rotation, but it will just displace in this direction. So you have 4. This is at 5. Beam element, you have K, 12, then you have 6, EI, L square, and then you have
minus 12.
minus 12, right? Is it?
Yes.
Then you will have here 6 EI, A over L, right? So, and so on. Then 1, 2, 3, 4. So whatever, there is no difference between the local and global in this case, because numbered such a way, it will remain the same, right? 1, 2, 3, 4. Now for the bar element, we have K, which is 2 by 2, and you write EI, EA over L over 2 is the length, so we write like this.
So can you please explain the degree of freedom 5 again?
Degree of freedom 5, what is, this is like a truss element. Truss element has what? Degree of freedom will be along this bar only, right? This is oriented upward. So degree of freedom for this one will be 1, 3 is aligned with 3, and you have the 5th one, right? So we have here 1, minus 1, minus 1, 1. Then you have these two, right? So you can, this is 3, this is 4, right? So you, 3 and 5, so you write 3, 5. Yeah. That's it. Now you assemble it. So only where there is a like interaction between 3 and 5 you will get. So finally you will get 3, 3 you are going to add. So whatever the value of here, this will be added, this will be added there. There is no, right? When you finally assemble, and you have finally assemble it, right? Such a way, you have this value here. You have K11, K12, and so you also have, you have K33, K35, K53, K55. So assemble them, you will get 5 by 5 matrix. What will be U? So the global will be, let's call this one as K11, K12, K13, K14, okay, and so on. Oh, this is for beam, okay, so I will also write for beam, KB, KB, KB. So we will get here K11, B, K12, B, K13, B, K14, B, and so on. Now when it comes to K33, we are going to add what? This one, A, 2EA over L, right? 2EA over L. So here you will have this. And then as 3, it will be added together, right? And then you will have at 3, 5. So let's do, here you have K, 14B, it will be 0 here, right? You have some value here, you will get 0 here also. Here you will get minus 2A over L. Then you will have, so this is 1, 2, 3, 4, and you will have 5. 5, you will get minus 2A over L, right? And then you have here 2A over L, right? Rest you fill. Rest as they are coming from the beam. You will also have zeros here. Again, 1, 2, 3, 4, 5, 0 here also. Okay? This is how you combine global matrix. Okay, and then U vector, you find out you will have 0, 0, and then what is the value here? Do you know this now? Now it is not fixed, so it is not 0. So you don't know that. So you say U, X, 3, Y, right? Then you have theta 3. Then you will have U, Y. Not 5. This is 0.3, right? So you call it node 1, 2, 3. So what number? What?
it will be 0.
Ah, it will be 0. So now it has 2 degrees of freedom which are unknown. Then you have to solve. Then F will be equal to what? The first one, remember, you get P naught L over 2. What is the next one? You have got minus P naught. You have to really find out. So minus P naught, then L. L squared, no? 12, right? P naught over L minus P naught L square over 12. Now sign we have to see whether we got this for this guy. This one we don't know. Yeah, so we have to check the sign. Right? It may be the same sign, but we have to check it. Yeah. No, it will not be same sign. Why? Because see here, if it goes up like this, right? So forces, of course, you will go here and here. But when it comes to moment, yeah, so this go like this will go like this. So positive here or negative here, positive here. Hence it will be plus, this will be minus. Yeah. So you can also apply your understanding, your insight there, and you know that if it is minus here, it will be plus. So like this. So these are the forces because of P naught, which is going here. Yeah. Of course, there will be reaction here. So remember that you will have also plus R1 plus R2. There is no reaction. Then here you will have force equal to 0, right? So it will have plus R3, R5. Then you solve it, right?
By 3 should be written U by 2 or U by 3.
Where?
Since we are talking about U to U.
No, this is Y2. This is node number 2. Any questions? So this is insight, so it's not possible to solve all questions. There are infinite number of problems in the world. Yeah. But if you understand, you can break into easier problems and you can solve it. Right? You can also have a 3D problem. Then what do? You can bend in this direction, bend in this direction. Right? There could be 3 kinds of moment. You fix it here. There will be a moment it goes like this. There's a moment like goes like this. There's a moment like goes like this. It will be a torsion. So you add a stiffness matrix of the torsion in this case. It goes like this one. You add a stiffness matrix for the bending this direction. Then for this also bending in that direction. Accordingly, there will be 3 kind of forces as well. If it is force axial load, you apply a truss element, right? Then if you have a force like this one, then it goes to bending or shear. This becomes shear, so that gives you bending. Similarly, the force in this direction will also give you bending. This is your shear. Right? So that means 2 bending element and 1 the axial element and 1 torsion element. You combine them together, you complete the picture. Right? You can do it that way. Independent, because they are all independent. Right? They are all independent. So they can bend in this direction at the same time it also bend in this direction. 3D bending. Right? So all are independent to each other. Of course, they will add to each other. Right? All are. You have to take the algebraic sum of all of them. Then you will see that because of some, you can see the interplay. Let us say you have a structure like this. Then what happens? You fix this. I apply load here. Then what happens? This will be a bending for it. This is for this, it will be torsion. Automatically solves. You can take a 3D frame, right? So it goes from here to here. Let us say one more like this. You can apply or like some oblique force here. Automatically you will see that there will be a combined axial, torsion, bending in all the 3. Solve it. Yeah. So only thing degree of freedom will be how many? Per node it will be all combined, all possibilities combined. How many degree of freedom? You will have this, you will have this one, right? And then you will have this way also, right? 3 like this, then you will have this, right? Right? Then you will have in this direction, like this, yeah, about this axis, right? And one will be torsion as well. So 6 degree of freedom plus 6 here, total 12 degree. Yeah, so you get the 6, 6, 12 by 12 matrix. Yeah, and you don't have to derive together. They are all independent. 2 beam element, 1 truss element, and 1 torsion element. You combine them, and you are done. Any question, guys? Okay, there's no question. See you guys tomorrow.